Hey guys, today we are looking at solving exponential and log equations. So we're just going to jump right in and start looking at some examples of these. So if b to the x equals b to the y, then x equals y. So the key here is that those b's are the same. We have the same bases. And when we have the same bases, we can just kind of cancel them out and set those equal to each other. So right now I have a base of 2 and a base of 32. Not the same, but we need to come up with something that would make them the same. So I know that 32 I can rewrite as 2 to the 5th. So I'm going to leave this 2 to the 4x alone. And then I'm going to rewrite this as 2 to the 5th. But then I have this x minus 1 here. So then those 2's can go away. And I have 4x is equal to 5 times x minus 1. So then 4x equals 5x minus 5. Subtract 5x from both sides. So I get negative 1x is equal to negative 5. Divide by negative 1. X equals 5. Now you always want to check on these that they do plug back in and they do work. So 4 times 5 is 20, so 2 to the 20th would equal, this is 5 minus 1 is 4, so that would be 2 to the 20th as well. That would give us the same thing. Alright, when bases are not the same and there's no way to make them the same, we have to take the log of both sides. And we can be smart about how we're taking the log of both sides, because we can do something that's going to help us cancel it out. So we know when the base is the same in a log that those will cancel. So that means I'm going to use a base of 4 to take the log of both sides. So then I have these cancel, and x equals log of 15 base 4. You'll notice by doing that, I just got the same answer as if I flipped it around to be a log function. Now you can type that log of 15 base 4. If it's wanting a numerical answer, you can use change of base, log of 15 over log of 4, type it in your calculator, get a numerical answer as well. So just focusing on the solving here, but depending on what it's asking for, go ahead and find that. So here, before I go to solve this, I'm going to, before I go to take the log of both sides, I need to isolate the exponent by itself. So I need to subtract 3 first. It looks like we could change that 25 into a 5 squared, but we can't because that plus 3 is there, which really means we have 22, and then I can't do anything with that. So again, I'm going to use that same base that I have, so I'm going to use a log base 5 on both sides. So then those cancel, and now I don't just have x, I have x plus 2 is equal to log of 22 base 5. So then I need to subtract 2 from both sides. So I have x equals log of 22 base 5 minus 2. Now again, if you're solving this, if you need to plug into your calculator, you're going to use log of 22 over log of 5, and then we would do minus 2. Plug that in, find out what that x value is. Alright, Newton's law of cooling. So this is the law of cooling. T is your temperature after so many minutes. So temp after T minutes, where this little t then is time in minutes. T sub 0, we know anything with the sub 0 refers to the initial. Where do we start? So the initial temperature. T sub R is the surrounding temperature. A lot of times this will be the room temperature, if that helps you to remember the T sub R, and there's another T sub R over there. And then R is your cooling rate. Notice there's a negative up there with that negative RT exponent. So, talking chicken noodle soup. Chicken noodle soup has a cooling rate of 0.46. That's your R value. I'm going to write R here since it got stuck up there. Room temperature is 70 degrees. The temperature coming off of the stove is 212 degrees. How long will it take the soup to cool off to 90 degrees? So let's plug in all of the pieces here. We know our temperature that we want to get to is 90 degrees. That's the temperature after so many minutes. Our initial temperature when it comes off the stove is 212. The surrounding temperature, the room temperature, is 70 times e to the negative 0.46 is our cooling rate. We don't know T. And then plus our room temperature of 70. All right, so now we need to start to solve this. So I'm going to do a couple things at once. I'm going to subtract 70 from both sides. So then I have 20 over here, and then I'm going to go ahead and do 212 minus 70, which is 142. So my goal is to try to get this e to the power all by itself. So then since it's being multiplied by 142, I'm going to divide it by 142. So 20 over 142, that'll reduce to 10 over 71. They both divide by 2. And I have e to the negative 0.46 t. All right. Remember when we want to switch things over, our base e is our natural log. So we have the natural log of 10 over 71 is equal to negative 0.46 t. Now we want to get t by itself, so we're going to divide by negative 0.46. This is where you definitely need the graphing calculator. When you put it in the graphing calculator, make sure you put parentheses around that 10 over 71. Close off those parentheses before dividing by negative 0.46. If you have typed it incorrectly, you should get that t is about 4.26 minutes. So I know that next time you make your chicken noodle soup, you will calculate when it will be the perfect 90-degree temperature coming off of the stove and wait that time until then. I'm sure you will do that. All right, solving log equations. So same kind of thing here. If we know that the bases are the same, log base b of x and log base b of y, then we know that we can just set x equal to y. So in this case, I see that we have log base 4. So that means pretty much these just go away, and we have x plus 3 is equal to 8x plus 17. So I'm going to solve this. And so I'm going to subtract x from both sides because I like to keep the x positive. So I have 7x plus 17. I'm going to subtract 17 from both sides, so I get negative 14 is equal to 7x. Divide by 7. Negative 2 is equal to x. So now you always want to double check. If I plug that in, is it still okay? Because we can't take a log of a negative number. So negative 2 plus 3 still gives me a 1 there. And then 8 times negative 2 plus 17 that still gives me a 1. So I have log of 1 base 4 on both sides. That's correct. Okay, when you have a single log, we have to switch it to an exponential and then check for extraneous solutions. So check for those solutions that don't work. So in this case, since my base is 4, I have 4 to the second is equal to x plus 3. That's really nice to solve now. So 4 squared is 16 is equal to x plus 3. I'm going to subtract 3 from both sides, so x equals 13. So you want to double check. If I plug in 13 plus 3, that's 16. Log of 16 base 4 really does equal 2. That one's okay. So now, this one, I'm going to combine these logs together so that I can switch it over because I only want one log base 2. Since I'm adding, I'm multiplying here. So x times x minus 7 is equal to 3. So then I am going to go ahead and multiply these out. So I have log base 2 of x squared minus 7x equals 3. And then I'm going to switch it over. So I have 2 to the 3 equals x squared minus 7x. Well, 2 to the third power is 8. So I have x squared minus 7x equals 8. So I'm going to go ahead and move that over. So x squared minus 7x minus 8 equals 0. And then let's see what I can factor. So I need two numbers that multiply to negative 8 and add up to negative 7. Well, that should be negative 8 and positive 1. So if both of those equal 0, then I have x equals 8, and I have x equals negative 1. So you want to look back at your original problem. Can I plug both of those values in? I can plug 8 in, no problem, but that negative 1 is extraneous because we can't have a negative plugged into our log. So x equals 8 is our only answer there. All right, that's all we had to cover today. If you have any questions, come see me in class, or come see me. Otherwise, I will see you in class.